Okay, so now we are going to study a quantitative problem here that involves circuits. So in this problem, there are two parts to the question. First, we're going to find how much current flows through R1. And second, we're going to find the potential difference between points A and B in the circuit. So here's a picture of the circuit. All right, the main concepts here are Kirchhoff's voltage law, potential difference, and Ohm's law. All right, so this is our given and hidden information. So as you can see, I listed the given info and then I wrote it in on the circuit. So we know that R1 is 1.70 ohms, R2 is 4.30 ohms, R3 is 9.00 ohms, V1 is 6 volts and V2 is 9 volts. All right, so the final quantities that we're solving for, in part A, we're gonna find the current through R1, which is right here, and we measure current in amps, which we notate as A. And in part B, we're solving for the potential difference, or you can consider that delta V, between A and B, and that unit is volts. Okay, and then to predict, so that we can compare at the end, I predicted a range between 1 amps and 5 amps, because when you consider V equals IR, you can conclude that the current cannot really be much more than 5, and it's definitely not going to be much more than 1 to make sense at any point on the circuit. Okay, to start solving in variable form, I have just used two of the equations. This equation's from the second loop, and I combine them to solve for I1, and that is just the first step to do part A. Okay, so continuing with variable form, I put the equation found in the last part into the equation for the first loop on the circuit, and we get this equation. And feel free to pause at any point to check if your algebra is also matching up. Okay, so in the final step here, I've put the equation we found in the previous portion into the equation for the first loop, and you get this very big equation to solve for I1, but keep in mind this is just for part 1. Okay, so for part A, I simply took the equation that we solved for and plugged in our known values to get that I1 is equal to 9.33 amps. And so for part B, we're just going to take that value and plug it right in. All right, so in this part, I just plugged in the equation for I2 that I found earlier and multiplied by R2 to get the voltage across A and B. And I also wanted to point out that I am predicting that the answer will be between negative 10 volts and negative 1 volts. All right, so now I plugged in my values into the equation we found for part B and got that the voltage across A and B would be negative 2.7133. Okay, so both of the answers that we found for part A and B were within the predicted values, so that's a good sign that we got the correct answer.